Okay, this is our second review for our second quiz in Algebra 2 for Unit 1. And so we're just going to work through this together. So feel free to pause it, replay it, slow it down, speed it up, skim through it, whatever you need, because we need to make sure we're ready for our quiz, okay? So this covers sections 1-1 through 1-6. So it's basically, if you remember, the lessons are really the same. It's just the functions that are changing and how they look and how we can answer these key characteristics. So let's go ahead and get started. So this is definitely no calculator part, just like before, there's a no calculator part and a calculator part. So it says, given this function, state the characteristics. All right, so of course this is a square root function. And so what I always like to do first is kind of sketch what we think it's going to look like. That's going to help me with the domain and the range and the end behavior. The others, the vertex, the transformations, I know those right now, but I'm definitely going to sketch what it looks like first. Now remember, the parent function of a square root kind of looks like the arm, like it's coming out like this. All right, but now we've got all these things going on with it. Now, it's a positive 2, so it's not like flipped or anything, but it is stretched, and the vertex is going to be at -1, -5. So we're going from the parent function, it would be down, back 1, down 5. So like at -5 and -1. This is just me thinking through it, okay? These are the things I know about it. And it's going to, I mean, it will be stretched by 2, but that's really not going to affect its domain and range. And so it's going to kind of look like this. So now that I know this and have it in my head, I can answer these questions, okay? So well, what is the domain? The domain is all the x's. And how far back to the left does this graph go? It goes back to -1. So it does not tell me how to list the characteristics. And so I like saying, I like interval notation. So I go back to -1 and it is included. That's the furthest back it goes. And it goes forever to the right. So it's -1 infinity. Now, again, you could have done inequality notation. You could have even written set builder. It didn't tell me how to write it. So I don't need to write it a specific way. Same thing with range. Remember, we're always how far to the bottom does the graph go and how far to the top. So we always list it bottom to top. Well, the range here, it's going to go down. The furthest point it goes down is -5, and then it's going to go up forever in the positive direction. So that's its range. Now its vertex, just me thinking it through a while ago, I know what the vertex is. It's -1, -5. And then let's list the transformations. Well, there's no negative, but there is a 2. So I know that it is a stretch because it's bigger than 1 and it's by a factor of 2. I also know that it has been shifted left 1 because H lies, and it has gone down 5 because K tells the truth. Okay, well, let's talk about its end behavior. Its end behavior is as x goes to infinity, f of x is actually, let me pause for a second. So it's asking what happens to x as we approach negative infinity. Well, it's not doing anything because it stops. So this is the one where we say it's like NA, right? Like it's not applicable. We don't have one in this case uh, where we are just we would go forever. But as x approaches positive infinity, we know we are going forever in the positive infinity direction. Use the graph to the right um, to Okay, sorry, I'm kind of distracted. I was looking through other papers. Okay, so this is this one. All right, number 2. This is one where we really struggled in our first quiz, and I take partial responsibility for that. And so we're going to make sure we hit this hard, and hopefully we're getting better at it with all the warm-ups and things we've been doing. So my domain is my x values, and my range is my y values, and we need to write it in all 3 notations. Okay, so I've got this quadratic here, and we are going to list it. And notice that it asks for it in different order. Okay, normally it says inequality, I'm sorry, normally it says interval, inequality, and then set builder. And you know what? You can still do it in that order. Pick the order that works best for you. I've told you a million times, I like interval notation. It helps me think it through. It makes me think, how it should look. And then I can go back and do the others. And then remember, inequality just fits inside set builder. So we can kind of go in our own order. There's no right or wrong and no specific order you have to go into. So looking at this, how far to the left does my graph go and how far to the right? Well, you can see the arrows on the end. So I know that using interval notation, I'm going from negative infinity to positive infinity. Okay. Now, inequality notation is really the same thing. You're just saying now where your x's lie in between. And so I always start with that. Just like, hey, x is going to go in between. But what do we know? It's negative infinity to positive infinity. Once you've done your thinking through the first part of what the domain is, everything else is just like, how do we write it? It's not changing the domain. And of course, we can't put the lines under the inequality symbols because the infinities are not included, of course. There's no hard stop. Now with set builder notation, you can say all the x's such that, and then just put your inequality symbols in there, your inequality notation. Okay, so we can just say x is such that x is in between that. So even though it asked me for it in different orders, I can still do it in whatever order I like. And so, like I said, I like doing interval first. It helps me think it through. Then I do inequality because then inequality just fits inside set builder. Okay. So let's look at our range. Now remember our range is our y values. So how far to the bottom does this graph go? And then we list it from the bottom to the top. Okay. Now again, I'm starting with interval. So interval, the lowest that this graph goes is 0. But the highest that it goes is positive infinity. Now 0 is going to have a hard bracket on it because it stops and 0 is included. Okay. But it's going to go on forever for infinity. Now, I'm going to go ahead and jump up and do inequality notation. Inequality notation is just going to tell me, remember, start it out like that. Then we can go put in our numbers. Then we can go decide if they're included or not. So we've already done the thinking. We know that it goes to 0 and goes up to infinity. So y is in between 0 and positive infinity. But I am going to have to put the or equal to sign on there because 0 was included. It went down to 0. Set builder notation is just putting that fancy, it's the set of y's such that, and then you just put the inequality symbols or the inequality notation in there. So you've just rewritten it now and made it look a bit fancier. Okay, so just because it asked for it in a different order does not mean you have to do it in a different order. All right, number 3, given the function, state the characteristics. So again, anytime I'm given this, I like to sketch out what I know it's going to look like. Okay, now this says x squared, so I know it's a quadratic. Okay, and then it does have some transformations to it. So I like to think first, what does the parent look like? Okay, so the parent's going to kind of look like this. I know that's not the best drawing, but that's okay. It's just a sketch. And I do know that it's going to be flipped upside down because it's got a rocks, a reflection over x, and then it's going to be shifted up 3. So you can just kind of quickly sketch it. We know it's going to go up to 3 and flipped down. That is what it's going to look like after all these transformations. So that helps me think through because we're really good at knowing the transformations. So let's just sketch it and then we have something to look at. Now, it didn't tell me how to answer my domains. So I'm just going to like mix it up a little bit. But again, you can answer it in set builder, you can answer it in interval, you can answer it in inequality. It's whatever you want. So the domain again is all the x's. Okay, so there's arrows on the end. How far to the left do we go? How far to the right do we go? We are going to say that the x's, whoops, not included, sorry. It's going from negative infinity to positive infinity. You could have said the domain is all real numbers. You could have used interval notation and done soft brackets on both of them. As long as what you're saying is the same and correct, you're good. Okay, because it didn't specify. All right, our range. Now look at our range. We go to the bottom most point is negative infinity. It's going to go forever. And then how far up do we go? Well, we go to 3. Okay, see why this sketch is helpful? So that means all of our y's, if I'm going to stick with inequality notation, okay, the lowest point that we're going is negative infinity. And the highest point we're going is 3, and 3 is included. Okay, so that's all it is, guys. And you could have said y, you could have just said this part, y is less than or equal to 3, because that's also true. And it's not really telling me what specific way to write it. It's just as long as I'm making a true statement. All right, so its vertex is going to be at 0, 3, because there's not any like x minus h in the parentheses with it, right? So it's just x squared, so I know the h is 0. And again, looking at the sketch, this makes it really easy to see. This is going to be a max value because it's upside down, and it's got that max value at 3. Okay. All right, transformations. Well, we've got a rocks because it's flipped. Just follow it through. There is no h value, so there's no shift left or right. And so we know that then we just shift up 3. All right, well, let's look at the end behavior. As we go to the far side of the graph on the left, what's it doing as we approach negative infinity? Well, our graph is also going down to negative infinity. And as we go to the right, our graph is also approaching negative infinity. Okay, so that's what we're doing. Okay, all right, next page. We are graphing some other ones. Okay. All right. So if you look at this, this is the cube root. Okay. The cube root function is the one that looks like the Egyptian, right? It looks like like the parent looks like this. All right. So just think about what it should look like, and then you can go from there, right? All right, so we've got the cube root and we've got a transformation, we've got a shift, we can see all these things. If you want to, you can think through the transformations first. So I know that it's going to be stretched by a factor of 3, and I know it's going to be shifted right 2. So anytime we are graphing, we've got to come up with some points and some movements. And so let's go ahead and do that. Now remember, whatever our x is that we're going to plug in, we have to be able to take the cube root of it. And so think about what numbers make sense, because I can't always take the cube root of nice numbers, right? And the cube root function has stuff going on the positive and the negative side. So I'm going to try -8, -1, 1, and 8 just because I can take the cube root of those numbers. Okay, that's why I'm picking those numbers, things that I can easily take the cube root of. So the cube root of 8, -8 is -2. The cube root of -1 is -1. The cube root of 1 is 1, and the cube root of 8 is 2. Okay? Once we have that table kind of established, we always look back and see if there's an a value. And of course there is, so we need to multiply those movements by +3. So that's going to be -6. -1 times 3 is -3. 1 times 3 is 3. And 2 times 3 is 6. Okay, now I've got my movements. All right, the next thing I need to do, and probably, I don't know, I guess it doesn't matter whether it's first or not, but let's figure out where I'm starting. My vertex, or they call it the point of inflection, right? The point of inflection, because it's like a turnaround point, right? So it is going to be at 2, 0, because remember, H lies, and then there is no K. So it's going to be shifted to the right 2, and we already knew that because we knew the transformation, right? So from our vertex, we're going back 8 and down 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Then from the vertex, we're going back 1 and down 3. 2, 3. Then we're going right 1 and up 3. And then we're going to the right 8 and up 6. 2, 6, 7, 8, 1, 2, 6. All right. And then we're going to connect them, and we know this is going to look like an Egyptian dance kind of, and yeah, that's it, okay? So now that we have this, I always like to save this stuff until I'm actually looking at it, okay? So the domain, of course, is all real numbers. You could have, like this is the quick way to write that. You could have written it as negative infinity to infinity. It's whatever you want to write because it's true. And the range is also going to be all real numbers. And again, you could have written it a different way, but this is kind of the quick way when it's not telling you what to do. So as x is approaching negative infinity, as we're going to this side of the graph, my graph is also going to negative infinity. And as I'm going and approaching positive infinity, my graph is also going to positive infinity. Okay? All right, well, let's look at this one. Now, you got to be really careful when you're reading these graphs because it's a mixture. We now know several different kinds of graphs. We know quadratics, we know square roots, we know cube roots, we know cubic. So there's lots of ones that we know, okay? So look at it. This is a square root. So think about what the parent of a square root looks like. It looks like this, okay? Keep that in mind. All right, well, let's go ahead. We can look at it as transformations if you want. There is going to be a rock, so it's going to be reflected across the X. It's going to be compressed, so it's going to look shorter and kind of fatter, and it's compressed by a factor of 2. Remember, we don't put the fraction because the word compressed means it's a fraction, okay? And then there's no H value, so it's not shifted left or right, but we are shifting down 4. Okay, so let's go ahead and set our table. Now, when we're thinking about it, what we're going to have to do, because the parent function tells us it's the square root, okay? So whatever number we pick here, we're going to have to be able to take the square root of it easily. Now, up here, we picked negatives because our graph, our parent function, does go into the negatives, and so it's okay to pick some negatives. But does our parent function of a square root go into the negative land? And it does not. So we are not worried about negatives because we can't take square roots of negatives yet, okay? So, can I take the square root of 1 easily? Yeah, so we're going to do 1. I can't take the square root of 2 easily or 3, but I could do 4 because the square root of 4 is 2. And then the 9, I could do square root of 9 really quick, and that would be 3. So that's why I'm picking these numbers, okay? I'm trying to do the math that would be easy for me, okay? So, do we have an a value? Yes, we do. So we're going to multiply by negative 1/2. 1 times negative a half, I'm just going to write it as a decimal. 2 times negative a half is negative 1, and 3 times negative a half is negative 1/2. Okay, let's go ahead and graph it. So our vertex is going to be 0, -4, because there is no h, there's no shift, but we are going down 4 with the k. So 0, -4, and then we're moving, okay? From the vertex, if I go right 1, I'm going down a half. I'm going right 4, down 1, and then I'm going right 9 and down 1/2. 1/2. Okay, now I knew this would be like a really short, not much of a curve kind of graph because it's being compressed and it's got a rocks, so it's upside down. Okay, now that I have it graphed, I can go and tell some info. All right, so what is the domain? Remember, the domain is the x values, and we're always worried from left to right. So what is the furthest left point of this graph? Well, it's 0. And again, it doesn't tell me how to write it, so I'm going to write it in interval because 0 is included because that's where it stops, but it does go forever in the positive direction. So we go from 0 to infinity, and 0 is included. Well, let's talk about the range. The range is your y values. Okay. So the range, how far from the bottom or how far to the bottom do we go? How far to the top? And then we list it from the bottom to the top. All right. Now you can see here this graph is going to go down forever. Okay. So we are coming from negative infinity from the most bottom point. And how far up are we going? Well, on the y-axis, we're going up to 4. Okay. So we're going up. Oh, sorry, that would be -4, okay? And -4 is included. So that's what your range would look like. Again, I kind of default to interval notation. You can do whatever makes sense for you. Okay. All right. The last thing I need to ask here is as it goes to negative infinity, what are my, like the end behavior, right? So as my graph is going to negative infinity, I get to say in A because there's nothing past 0. So that's really kind of not a point to talk about. But as we are going to positive infinity, what is this graph doing? It's going to go down forever to negative infinity because of the rocks. All right, next one. Here we have this. And again, be very, very careful as to what kind of graph it is. This is a squared, otherwise known as a quadratic. So its graph, parent-wise, looks like this. Okay, now lots of stuff going on there, so let's figure it out. It asks me what my vertex is. I can look at this and tell that my vertex is -3, 7. H lies, K tells the truth. The other stuff I'm going to leave. I mean, I guess we could fill in transformations, huh? There we go. I know it's going to have a rocks. It's a reflection over X. It's going to be shifted. It says +3, so I know it's going to be shifted to the left 3 because H lies. And then I know it's going to go up 7. Okay. All right. So vertex we said was -3, 7. So this is our starting point. And let's go ahead and make a table. Now remember, when we do our x's, we're going to find things that we can easily square, which honestly, that's easy because you can square any number, right? Now, the thing is, what I think about is when we do this, it's symmetrical, right? So if I do something like if I say I go to the right one, I also know the same thing's going to happen when I go to the left one, okay? So when I put 1 there, I really don't need to write +1 or -1 because I know it's going to happen on both sides because the parent is symmetrical, okay? So 1 squared is 1. If I went to the left or the right for 2, I know that it would be 4. And if I moved to the left or the right for 3, I know it would be 9. Okay, now remember, we're doing the same thing. We're just picking numbers that are easy to square. And technically, these are included as our negatives because the same thing happens on both sides because it's symmetrical. Do I have an A value? Not really a separate number, but it is a negative. So you can think about it like a -1. So all that's going to do is change the sign. Okay. So let's go ahead and plot. So from here, I could go left 1 and down 1, but then that also means I could go right 1 and down 1. Left 2, down 4, but it could also happen on this side because we're symmetrical. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there we go. Okay, go ahead and connect your points. There we go. All right. Now that we have our picture, we can answer some questions. What is our domain? Okay, remember domain is your x values, and it's not telling me how to write it, so you do what makes sense to you. The domain is all your x values. How far to the left does this graph go? How far to the right does this graph go? And it actually is going forever in both directions. So we can easily say all real numbers. That's an R. It looks like a weird. Let me fix that. There we go. Okay. Now the range is your y values. It's not that simple, but you're always listing it like from the bottom to the top. So how far does the graph go down? Well, it goes to negative infinity. How far does the graph go up? It goes up to 7. So I know that we are coming from negative infinity going up to 7, and 7 is included. Okay, let's talk end behavior. On the left side of the graph, as we go to negative infinity, my graph is also going to negative infinity. And as I go to the right, it's also going to negative infinity. Okay? All right, let's keep on going. Last one. Nope, I lied. Okay, so again, pay attention to what is happening. All right? This is a cubic function because of this 3. The parent of a cubic function looks like this. That's the parent, okay? But we at least know what it's going to look like when we are done, okay? I don't want to say domain and range yet because I like to look at the picture, but I can say the transformations. It's being compressed by a factor of 2. And that's because it's 1/2, right? I know it's going to be compressed. I know it's going to be shifted. It's going to shift left 2 because H lies. And I know it's going to be shifted down 2 because K tells the truth. So now I'm kind of thinking it through, and we got to pick some points. Now remember, pick your points that's going to make it easy to cube. All right. And we do have a negative side of the graph. We do have a positive side. And so if we picked, but they're not symmetrical, so it doesn't work like it does with quadratics. So remember, if I picked 1, 2, and 3, that would be, I would be moving like up to like 27, and that will never fit on our graph. Plus, we want to see some negative sides of things. So what if we just said like -2, -1? If I say 0, that's not going to help me because 0 cubed is still 0. So, and then 1 and 2. Okay, so I've got some smaller negative numbers to see what's happening. I've got some bigger or smaller positive numbers, and I'm pretty confident these will all fit on the graph. All right, so let's cube them. -2 cubed is -2 times -2 times -2, so it's -8. -1 cubed is -1. 1 cubed is 1, and 2 cubed is 8. So these are my movements, but we got to pay attention to if there's an a value. And there is. It's +1/2, so we're going to multiply. Half of -8 is -4. Half of -1 is -1/2. Half of 1 is 1/2, and half of 8 is 4. Okay, so this is the movements we're actually doing. All right, so our starting point, though, we've got it's -2, -2. We pick it out just the same as we have in all the other ones. So we've got -2, -2. That's my starting point, my vertex, my point of inflection, vertex. Um, and so, no, probably a point of inflection. All right, either way, it's the same thing. So we went back 2 and down 4. 1, 2, 3, 4. Back 1, down 1/2, right 1, up 1/2, and right 2 and up 4. Connect your points. There we go. Okay. Now that we've got a picture and, that's what I was expecting. This is why I like to think through all this stuff. So that's what I was expecting. What is the end behavior doing? Well, as we go to the negative infinity side, my graph is also going to negative infinity. And as I'm going to the positive infinity side, my graph is also going to positive infinity. The domain would be all real numbers because it's covering everything. And the range would also be all real numbers because it's going up and down forever. And again, that's the quick way to write it. You could write it however you want. All right, given the parent function, the cube root of x, and the transformations, graph the new function. Okay, now I always think it through first. The reflection across the x means there is a negative. A vertical translation, that's another word for shift, up 2 means that our k is 2 because it tells the truth. The horizontal translation left. Horizontal translation is just horizontal shift, which means that's your H, right? But we do know that H lies. And so if it says we're going to go left 1 unit, we're going to write that as +1. Okay? And then it's a vertical stretch of 2, so I know that my number out in front is 2. All right, let's turn this into this. All right, so we've got f of x, you could use y. I know that out in front it's a negative and a 2. So the rocks and the 2 for the stretch. And then I do have an h value, and I know the h value always goes with the x. Don't forget your little cube there. That's going to make a difference. And I know that the h is always associated with the x, whether it's inside the parentheses for a quadratic or whether it's under the radical sign for a root function. So we're going to say h, or we said h was plus 1, so we're going to say plus 1. And then we say k is 2 because it tells the truth. So here's the function, okay? And then we're going to graph it. So I know that my starting point is negative 1, 2, negative 1, 2. And now I need to make a quick little table. Now remember, I'm trying to find the cube root of whatever I'm plugging in. So let's pick some easy ones to take the cube root of. And we know that cube root functions have things going on the left side and the right side, the negative side and the positive side. So let's pick some negative numbers and then pick some positive numbers that are easy to take the cube root of, okay? So the cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1. The cube root of 1 is 1, and the cube root of 8 is 2. All right, so let's pay attention. We do have an a value, which means we're multiplying by that. So it'll be negative 2. Negative 2 times negative 2 is positive 4. Negative 1 times negative 2 is positive 2. 1 times negative 2, 2 times negative 2. There we go. Well, let's go ahead and do that. So I'm going to go back 8 and up 4. 2, 3, 6, 4. Okay. Negative 1 and 2. 1 and negative 2. And 8 and down 4. Okay. Remember, your cube roots are kind of your Egyptian looking arms, right? In the hieroglyphics that they drew. So that's what we were expecting it to look like. It does have the rocks, so it's backwards from what we normally think, and it meets all the criteria. Okay? All right, well, let's go to number 9. We are graphing the heck out of this stuff, okay? So, because we need to make sure we are keeping it straight in our head. All right, this is a cube root function, and it says state the characteristics. It does not say graph. Woohoo! This is for this one. Okay, so all we're doing is stating the characteristics. The point of inflection, remember, is technically the same thing as the vertex. We treat it the same way, we find it the same way. So the cubic function is the one that looks like this. All right. So that's not what it looks like after all these transformations, but this is enough to get us thinking through. So once we know the parent looks like this, I know that it's going to be flipped because of the rocks. I know it's going to be shifted to the left 3 and down 2. So it's going to look something like this. Is this the most perfect form ever? No, but this is kind of what it is. Do you see how I just think through these to get it step by step? All right, so looking here, I can tell that my point of inflection is negative 3, negative 2, just like I've been reading them on every single graph. Now, the domain, once I have a picture, it's really easy to see. The domain is all real numbers. The range is all real numbers. As we go to the negative infinity side on this coordinate plane, we can see that our graph is going to positive infinity. And we can also see that we are going to negative infinity on our graph. All right. Okay, number 10. This is one from our previous sections, okay? So it's graph the inequality, all right? That means we have an inequality symbol. The fact that it says greater than or equal to means we're going to do a solid line. And, oh, good, this is a quadratic. So we're going to graph it just like we do. We're going to graph it with a solid line. And then the last thing we need to do is shade, okay? So I know my vertex by looking at this is 0, negative 8 because there's nothing with the x for the h value, right? So I'm going to come down here plot my vertex, and I need to come up with some points that will make it easy to square. Now remember, quadratics are like your little ones that look like this. So if I say that I'm going to go 1, I could really say that I'm going left 1 as well because they're symmetrical. And squaring numbers is really easy. So 1 squared is 1, 2 squared is 4, 3 squared is 9. All right, check for the a value. Ooh, I got 1. We're multiplied by 3. So 3, 4 times 3 is 12, 9 times 3 is 27. All right, some of these will not fit on there, but we're going to try the best we can. All right, so because it is a quadratic, and we know that these movements mean that I could go to the left one or to the right one. So let's graph it. If I go to the left one, I'm going to go up 3, but I also know because it's symmetrical, I'm going to the right one and up 3. I'm going to the left 2 and up 12. And then same thing, keep it symmetrical. I'm going to go to the right 2 and up 12. Obviously, I'm not going to fit 27 on there, so I'm just going to make do with what I got. Okay. Now, the last thing you have to do is go back and say, I'm shading all the y's that are greater than this line. Okay, so where do I shade where all the y's are greater? And you know what? I'm really not sure. I'm going to use what we call a test point. Now, this came from Algebra 2, or I'm sorry, this came from Algebra 1, and anytime I'm unsure, I'm going to use a test point of 0, 0. Okay? Now, what this tells me is I'm going to plug in 0 for x and 0 for y and see what I get. And if it's true, then I'm going to shade where 0, 0 is. And if it's false, I'm going to shade outside. Okay, so the test point idea came from Algebra 1. We haven't really talked about it in class because it hasn't been necessary, but that's what we're doing. So is 0, let's see, if we make x 0, that's going to be 0, and that's going to be minus 8. Okay, is 0 greater than or equal to -8? Yes, it is. So since 0, 0 is a true statement, made it true, that's where we're going to shade. Okay. All right. Almost done. Now, this is the part where you can use a calculator. And this is the part where, for the most part, you guys did okay on this one. But we just need to get better in this. So this is calculator stuff. Some of it will not be, like some of it will not, uh, like a calculator would not super duper help you on some of these, but we can try. All right, so before I even go through and pick these, I'm going to go through and think this through. So it's asking for the range. So I'm thinking about just the range. It's not asking about the domain, so I'm good. So the range here, remember how far down to how far up. So my lowest point on the y-axis is 2, but it's included, and then it's going on forever to infinity. So 2 to infinity. It has to go in that order, and 2 has to be included. Okay? What about negative infinity 2? Nope. See, once we think through it, it's not bad at all. What about negative infinity with 2 included? No. What about us saying y is greater than or equal to 2? Is that a true statement? Yeah, because we start at 2, we get bigger. So yeah, this one would be the true statement. Y is such that y is greater than or equal to 2. Well, yeah, that's just set builder. It's got that fancy part in there. And we know this is not true because it didn't say or equal to. 2 is included to infinity. Yep, that's the one we even said to think it through. Y is greater than 2? Nope. And 2 to infinity, but 2 is a soft bracket, not included, and that is incorrect. Okay, so your answers are C, D, and F. Number 12, consider the following ranges. So these are your y values again. Indicate which ones are equivalent. Now, I am a huge fan of sketching things before you pick them because just trying to look through and pick which ones are the same never really works out well. Okay, so we're talking range. I don't need to know what my graph looks like. I'm just going to think through what this means. This says all the set of y's such that y is greater than or equal to 8. So here's 8, and I'm just going to pretend right now it's a quadratic. And I don't know if it's quadratic, who cares? I'm just thinking it through. This says y is less than or equal to 8. Well, that would be like this way, right? Okay. This would say y is less than 8. So 8 is here, but it's not included. So I don't know how to really think through that. Maybe I'll just do an open circle or not. Maybe I'll just write not included to remind myself, okay? Y is greater than or equal to 8. So here's 8 and yeah. Y is greater than 8. So if here's 8, we'll say not included because it does say, so it looks like this, but I know it's not included. And then here we have 8, which is included, and it's going to infinity. So as we look through these, which ones are the same? So I can see that it looks like A, D, and F have kind of the same drawings. Yep, that's it. There you go. All right, 13. Identify the range. Hey, have you noticed I haven't even used a calculator yet? So just because they say you can use a calculator on this part doesn't mean it's beneficial, okay? So it says identify the range of the given graph in inequality notation. All right, so this is an easy one to start off with. I immediately know that A and B cannot even be answers because they're not in inequality notation. They're in interval notation. So let's see. Let's think it through. So it's -2 is the lowest point that it is. And I'm still going to think through it in interval notation though. -2 is included and it's going forever to positive infinity. Okay. Which one of those is saying the same thing, where it's everything is greater than or equal to -2? Boom, right there. Okay. I always like there is very few things that you can just jump in and do without thinking it through first. All right, use the graph to the right to answer true or false to the following statements. The equation of the function is x minus 1 squared. Well, that means it's going to be shifted to the right 1. Let's see here. Okay, and actually, you got to look even closer. This is a square. Actually, let me just back up. Let's think about everything we know about this one, okay? This is a cubic function, all right? So this is everything we should talk about should be x cubed. And it almost got me. That's why I stopped. Because when I'm looking at it, it does. I'm like, oh yeah, that's true. It shifted right. But it said squared. So that's why this is false. Okay? It's not that. If it would have said cubed, then yeah. So you got to be really careful, okay? The domain of the function is 1 is included and we go to infinity. No, that's false. Remember, the domain is your x values. We're going from negative infinity to positive infinity. The range is from negative infinity to positive infinity. That is true. And the x-intercept is 0, 1. Oh, they get us this like this every time. Here's the x-intercept, and it is at 1, but it's not 0, 1. It's 1, 0. Okay? So be really careful because they love to trip you up. All right. Now, I will argue that you needed no calculator to answer any of those calculator questions. But I will tell you that what you do need to know how to do for the calculator part is the ones that say sketch a complete graph and be able to find the zeros and the y-intercepts and the other key characteristics. Those are in your 1.5 and 1.6 practice in your notes and your practice. So just make sure you are aware of how to do that. And if you need help with that, you let me know.